Welcome to Mickey J Whitehat. Yesterday I uploaded a video and that video has caused lots of comments in Reddit and also to the video and to me personally. People are wanting to know what exactly was I dealing with. An exe file inside an image file, but what was that exe file? I know I pulled it apart to a certain point, but then the video got a bit long, so I stopped pulling it apart. A lot of people have suggested I could take it further. So on this video, we're going to take it further. Would you like to see what's in that exe? Before we get started, just a few things to note. A number of people have asked about Ghidra and they've asked about the tools I use. I put all the tools that I use and all the links in the description of the videos, and the knowledge I use within these videos is based on previous videos. So if you're wondering about Ghidra, have a look in my video stream for more videos. Wondering about virustotal or hybrid analysis or CFF Explorer or any of the tools, be sure to poke around in my videos and have a bit of a look. I can't recap them all in each video. The videos would be just too long. Anyway, today, what are we doing? Today we're playing with an executable that I really didn't get very far with. So let's see how we go today. Now, we already know that the file is malicious, so I'm going to recap by uploading it to our hybrid analysis, and here we are in hybrid analysis, just so that we know what we're looking for. This reads terminal services related keys, often RDP related. It posts files to a web server, not from but to. It writes data to a remote process, and it reads bits and pieces about the local machine. We know it's malicious because basically it tells us so. And inside here we can see it hooks in, plays around with the kernel, injects a process, it looks for credentials, it hooks in again, queries the registry, and supports remote desktop. So it's actually quite a malicious, nasty little tool. As we go down through the list of things, we can see here that it found an IP or a URL, so it's going up to that particular URL. We don't need to worry about is it malicious because we know it's malicious. Here we can see the it wrote to this particular location. So the file obviously uploaded into hybrid analysis, triggered and wrote there. We've got some artifacts of websites popping up, telling us it's going to go off to a whole heap of PHP websites and download various things. We can see IP addresses. We can see some network traffic. We can see it's got some anti-reverse engineering here, and the actual header for the PE is a bit unusual. Okay, granted, yes, it's unusual. We can see it reads a computer name. That's pretty boring. Posts to a web server. That's interesting. So here we go. It's going up. It's having communication with a web server, and it's posting something up using a PHP page. And keep scrolling down. Wow, there's quite a conversation to and fro here. Okay. And it's changed hosts a few times as well. Right. It reads configuration files. Okay. Creates a new process. It monitors specific registry key changes. That's interesting. So what is it looking for there? Current control set WinSock. Okay, so it's looking at the internet and network traffic. Sends traffic out on HTTP ports. So that's port 80. Which is interesting as well. Remote access related, reads the RDP, checks on FTP client related files, interesting. Opens file with deletion rights access or access rights. Unusual characteristics, hooks and patches the running process. Cool. Reads the registry. Wow, what doesn't this malware do? It connects to all sorts of things. It's got a nice interesting icon. It's got different file sections. It doesn't interact with the desktop at all. I'm starting to get a bit bored now, just scrolling down. Sorry about that. And it's got a lot of DNS queries and things like that, and contacted hosts. Jumps around the world. Does quite a bit actually. And there's a bunch of extracted strings. So this piece of malware is quite intriguing. What does it actually do? I'm going to load the file up into Ghidra. I've renamed it to payload.bin just so I don't accidentally run it. Now, one thing I should have mentioned about hybrid analysis while I was on there, if you're a registered logged on user, you can actually download the WinPCAP file, so you can put it into Wireshark and you can see the network traffic for yourself. You can also download any dumped files and things like that and pull them apart and get a bit more information about what's happening. I'm not going to do that today. I'm going to go straight for the payload and I'm going to analyze that. The first thing of note is that the headers seem to be not fully intact. They're a little bit unusual and not what I'm expecting. We do have the magic byte MZ, so it appears to be a valid PE header. If I scroll down, we should find the PE section. If we keep scrolling to here, and there we have PE. So we know that it's trying to execute within a Windows environment, but it doesn't quite look right. First thing I normally do is go to functions. One function. That is not normal. And the one function looks like it's actually running MS Core DLL. So let's look at the imports. One import. That's also very unusual. One import is usually a side effect of what I see in most executables that are being compiled with Visual Studio.NET. Having a look at this one function, I'm not going to get an awful lot out of that. In fact, it doesn't appear to have much code in it whatsoever. Let's go to the search for strings. The first thing that strikes me about this search for strings is I've got an awful lot of strings. For there to be only one function, then why are there so many strings? So something is wrong with this executable. It's somehow obfuscated or something's been done to it. I can see the strings. They are very unusual. They look like just any random two words out of the dictionary stuck together. I can see disables debacle bracketing.exe. I think there's a random name generator maybe. Maybe that's how it runs on the hard drive. Just randomly generates a name. Anyway, I can tell from going through this that it's just all random stuff. Nothing really stands out. These could be names of procedures that I'm not seeing. Under functions, I've only got the one function. So what would I do next? Because I've got this unknown random thing that I can't really decode it. Well, the first thing, I know that this is likely to be something to do with Visual Studio, and it looks like it's probably packed. So I'm going to search for the word reflection, which is an indicator, here we go, that it's been packed or compressed or whatever you want to call it, encrypted with Visual Studio. So everything I'm looking at is now out of my realm. It's still going to be too hard to decode. So there's the first clue, the word reflection. I'm going to exit out of Ghidra and have a bit more of a look at the header. But before I do, there is one thing you should note with these .NET compressed or packed files. Quite often, what a person writing malware will do is create an executable that's malicious. Then they'll write another executable that generates that second or first executable. And then they write another one after that. So it's their form of obfuscation. So you could have an executable that's several layers deep, and you need to remove each layer one at a time to generate the next executable. So what we're looking at here was a container that contains something within it. So we need to find out more about what's within it. Just for my own confirmation, I've loaded up PEID and I can see here that it is actually made with .NET. So this tells me from the header what created the product. Now, .NET products, there is actually a decompilation disassembly tool for .NET that's more effective than Ghidra, because it is designed specifically for .NET. So how about we fire that product up? Before I do fire that up, I need to know a bit more about this executable so I know what I'm looking for. I've used a tool called PortX Analyzer. That can dump out information about the executable and also give me an image representation of what I'm looking at. So if I have a look at this, and on your screen it will probably be fairly hard to read the text on this. Even on my screen it's hard to read. But you can see that the blue here represents the MS-DOS header. I can see that the light blue represents packed. So this whole section of code here is packed, which is what we expected because we couldn't read anything of it. We can see what the ASCII is, we can see what the resource tables are, but what's really interesting here is this big, large packed section. So there is something hiding within this executable. Obviously this external component is just to make that internal component run. So how about we get the text out of PortX and scan through that? Here we have the text out of port X, so we can see all the various aspects of this executable file. Now, what I'm really interested in is anything that's going to tip me off there's a problem. So as I'm scrolling down, 386 processes, whoa, here we go. Terminal server aware. Okay. So this thing knows it's running in a terminal server or not. That might be related to that hybrid analysis where it came up saying it uses remote desktop. There's the main section. We've got some icons. There's the internal name, disables debacles bracketing.exe. Obviously that's not the name of the file at the moment. And we've got all the hashes and bits and pieces. Malware probability is 50%. Yeah, I'd say 100%. Okay, next step. So the tool I'm going to use is DNSpy, .NET Spy, and here it is on my screen. There are some things that I like to do. First of all, because I'm recording this in a video and it's hard to see at the best of times, I'm just going to change the theme to being a bit of a lighter color. Just so it comes out better on the video. Now I'm going to bring in the file I want to look at. And the other thing I do in preparation is delete any of the other files by default that are listed in here, just so I've got just my file coming up on the screen. As you can see, I've got that one import, and then I've got underneath this, I've got the different sections of code and the PE header. So we are now playing in a tool that is native to .NET executables. Really cool things like I can change the code from C to Visual Basic. I can change it back, obviously, to C, just in case you're better with Visual Basic or not. I can also turn on debuggers, and I can put in breakpoints. So I'm at the point where I can run some of this code. The other cool thing is if you have .NET installed on your actual machine, you can actually take bits of the code out and compile it on .NET and look for the output. So instead of running the whole malicious code, you can run just sections of the code if you wish. This episode brought to you by the Virus Doctor. Yes, I pulled them apart, but he helps you get rid of them. So where I'm going to look first of all is the PE header. So we've got the DOS header, we've got the file header, we can see it's an executable, we've got the optional header. We can look through all these kinds of sections and bits and pieces, see if anything stands out. What I'm really doing is a bit of a hunt and peck approach. I'm hunting around and pecking at things, trying to find something of interest. I've got my references, resources, and this is where the code is. And if you recall from Ghidra, there's those strange names again. So they all look like two words out of the dictionary whacked together. And I think what they are is basically someone has created the classes or the bits of code in this C compiled .NET executable with these names to try and make it hard for people to guess what's going on. Just like in Ghidra, you click on things and it decompiles. This is a little bit more accurate because it's a .NET tool designed for .NET compiled executables. You can pretty much take this back into .NET, compile it, and it will work. So it's a little bit more accurate than the guessing that the Ghidra does from the assembly. To make things a little easier, I turn on the search, and here we have the search here, and I'm just going to search for HTTP just to see if anything comes out. In this point, we're actually getting HTTP from everything, so I want to make sure I'm only getting it from the file I'm in. There's nothing there. Let's search for the word password. Okay, there's nothing there. What about for keystrokes? Alright, we've got something here going on. Public key token. Okay, so what we just looked for was any mention of the word password. Password grabbers, generally the people who write the code, unless it obfuscated it, they like to know where they're at in their code, so they use the word password. And if they're tracking any keys for key pressers and key loggers, again, they usually put the word key in there. So at the moment, we're not coming up with anything we can actually easily find. The only thing we could do now is step through the code and work out what's going on. Obvious things would be a byte command where it's going to output a further executable, or, oh, here we go, we got some code, or we find some code that actually starts telling us what's going on. So this one here is getting the IP6 properties. What else have we got here? Alright, that might have been just a one-off lucky click. Again, hunt and peck. The rest of this code, it looks so obfuscated because one process or one function is doing one thing, and it's all going to get compiled up into something. So there's something more sinister going on here. I think I've only got to the first layer. Okay, because this looks so obfuscated, I'm going to try and use another tool. D for dot, which is up on GitHub, and I'll put links for that, which is for decompilation and also for de-obfuscation. Let's see what happens when I pass that binary file through that tool. Just to make it easier for myself, I've written a little batch file, so I'm just now going to run that and run d for dot over my payload.bin file. Again, that's that executable, I just renamed it. And here we have payload-cleaned. So my first job will be to pump that up through probably Ghidra or even dnspy and see what we can find out. So actually, first of all, let's start with dnspy. It's going to open that new binary. Here we go. Still looks fairly similar. Okay, I'm not seeing anything that stands out as being unique and new. Again, hunt and peck approach. We're going to be going through and just looking for the code as we come against it. Oh, here we go. Alright, so we're going to spend the time and basically manually go through trying to figure out what's going on. So this is what dnspy will be really good at, and obviously in dnspy, if we come across a binary file that's going to get exported out, then this is going to be how we're going to find it. Just by hunting and pecking or searching and going through it, turning on debug, seeing where it goes, and that's all we can do. Wow, look at this. We've actually got, wow, we've got a lot more functions. I would suggest that half of this file was obfuscated, and now look at all these functions. There's enough functions here to make me think each one generates a single character, and there's a master function somewhere that will run it all and put it into order. Here we go. This is building an array. Let's see if it's doing a byte. It's doing a byte array. Ooh, interesting. So this is creating a binary file. Let's see what we got here. Try. Still don't see anything being fed into it just yet, but that could be coming from another function. Okay, this is definitely getting interesting. Now, if I come across anything that creates an MZ header, I'll know it's popping out an exe file. This could be doing anything. It could be creating anything. So what I really would be interested in is if I see a byte array starting with 77,90, because 77,90 represents MZ. Again, hunting and pecking my way through, just trying to find things. So this, by the way, is a very long process. So I'm not going to video all of this because look at all these functions and procedures. Wow, there's just so much here. And it's been put in such a way that you don't really know where you're headed. Here we go, here's main. Why didn't I try and find that before? Here we go. So that's the main function. Interesting how de-obfuscation has popped this out. Now I'd be curious to compare that to Ghidra. So let's jump into Ghidra, shall we? And here we are with that same file. And we're going to open that with a code browser. So back in Ghidra, the first thing I notice is, check it out, we've got functions now. Last time we were here, we did not have functions. So that D for dot has definitely pulled a lot of information out for us. So it looks very similar to dnspy now, where I've got lots and lots of functions. Let's now go up and use the search for strings and see what new things we see there. Okay, here we go. Just some, whoops, something, runtime remoting metadata. Collection 1. I wonder if that could be referring to the collection 1 passwords that were found recently on the dark web. What else have we got here? Starting to pique my interest. Very interesting. Here we got those random names again. That's probably going to go for quite a bit. Oh, a lot more than last time. Let's get to something outside of this range of stuff. I still think each one of these refers to a function. I saw the word socket. There we go, sockets. Deliberating bucket. Problem with all this is you don't know what is a real name and what is a procedure or what, because of the way it's been done. Here we go. What do we got here? We got the file versions. We got the history. We can see its original EXE name. Wow, there is so much we could search through in there just in the strings alone, let alone in the code. So I think decompiling this on video right now and pulling it apart is of little value, because there is so much to weed through. It's going to take a long time to find anything meaningful. Yes, I could search, so let's search for the word password. Okay, let's search for the word key. Delete key, open sub key, okay. What about HTTP? No. What about www? No. What about IP? Oh, hits everywhere. There's all kinds of things. What about RDP? No. What about terminal? No. So there's so much we could now do from here to find out what's going on. It's just going to be hunting and pecking. So when faced with such a complicated, humongous mass of text, this is why I use hybrid analysis, because hybrid analysis is doing an assessment based on what it actually does, the outputs from this file. It looks at, does it query for a remote desktop? Does it output a file? Does it query through something like a packet dump? Is it going across the network to the internet? Is it querying DNS? If it did do that, did a file get transferred? Is a registry change occurring? Is there something going up into memory? So that's a much easier way to see what's going on, because in here, clearly it's obfuscated and made very hard for you to pull apart. Just having a look at the one function alone in Ghidra is a mind bender. Yes, you could spend the time. So you could find out what this variable is, and you could write name, and you could change the name of it. You can do that all the way through, but you would have to be really desperate to try and figure out what's going on, because it gets more and more and more complicated. The maths alone are incredible. All sorts of less than equal, times equal. Wow, there's just things being assigned left, right, and center. And this is just one function. You could step through all the functions, and it's all the same. It just gets very, very, very complicated. So between dnspy and Ghidra, you could pretty much figure out what's going on with this. I'm not going to get into that. As I said, it's horribly complicated. Not time for that on the video. But as per the people who said on my last video, hey, you could take it further and pull it apart. Well, there you go. It's done. We can pull it apart. We've unpacked an executable within an executable, and it's now spat out a lot more information. We've now even found the main function, which we couldn't previously, and we can now go through and try and figure out what's going on. My course of action from here would be use debug or something like that, and set some breakpoints and go through the code, pushing the start button one bit at a time to see where we go. But just be very careful with doing that kind of thing, because you are running live malware code on your machine, and obviously if you set the breakpoint at the wrong point, it'll execute something you don't want to execute, and before you know it, your machine is hosed, and you don't want that to happen. So look, yeah, thank you for those comments. Here's the video I promised I'd make because of those comments. Thank you for joining me, and if you've got a comment, leave it below the video, and obviously I'd love you to subscribe, and obviously share this with your friends, discuss it, talk about it, give me more hints and tricks, and yeah, aim of the game is to educate you all, so I hope you feel educated.